So here we make it to the very, very last bit of the semester, and I wish I could tell you it was a better story. But we're going to talk about humans' impact on the environment, and we are having one. Humans are rapidly changing the Earth. You're welcome, if you disagree with that statement, you're welcome to send me whatever research you have, and I'll direct you to all 100,000 papers that say otherwise. We are changing the planet. And one way that we're changing the planet, major way, is by moving nutrients. Most ecosystems are balanced. What comes in goes out. You know, the area is basically self-contained. What we do as humans is we move nutrients from one area to a new area. You guys, when you eat, are not eating food that's usually produced right here. We don't produce terribly much food right here. So all the nutrients that are going into that food from other parts of the world are all being funneled to you. You're eating it. And then what do? You excrete. You produce waste. That waste goes to a waste processing plant. That's where all the nutrients are now. So how do the plants and animals that were growing all the rest of the world get their nutrients? Usually what would happen in a balanced ecosystem is you grow your food, you eat, you excrete, you die, you return the nutrients to the environment. But right now, all those nutrients are coming to a totally different part of the world. So if we have too many nutrients here, and we do, we get these algal blooms growing in the river because, honestly, we've got too many nitrates from our food, from what we have being pumped out through sewage. What happens to the rest of the places where they're actually growing food? What do they have to do? Think about it. We've got all the nutrients they need over here. They're lacking nutrients. Yeah, they need to get it from somewhere. So they're going to end up using a lot of fertilizers, producing a lot of chemical fertilizers, a lot of ways of just trying to get nutrients back into the soil. It'd be ideal if they got it from us. It would be awesome, wouldn't it? It's like they would ship us food. We would literally ship them our waste. It's not the way it works, though. We are moving nutrients from an area in which the nutrients originally occurred to an entirely new area, leading to massive increases in one place and massive decreases in another. Questions or concerns? So what we have to do then is we're increasing the amount of nitrogen in the soil. We're constantly fertilizing the soil because we're usually taking nutrients out and we're never putting anything back in naturally. So we add chemical fertilizers. We're increasing nitrogen based on fossil fuel combustion. We're putting a whole bunch of nitrogen in the soil. And what is nitrogen used for? It's used for making amino acids, it's used for making proteins, which is a good thing. The downside is when there's too much nitrogen present. When there's too much nitrogen present, it becomes a detriment. Most plants in the biome are going to absorb nitrogen from the soil. But they can only absorb so much. There's a critical level after which, it's called the critical load, the plant can't absorb nutrients. In fact, you can use plants to take all sorts of things out of the environment. It's what's called bioremediation. They were experimenting with taking plants and putting them on nuclear irradiated soil. You put the plants in the soil, they absorb a lot of those radioactive isotopes, then you harvest the plants, and you safely dispose of the plants. How do you dispose of them? I don't know, you bury them. Which does what? Puts it right back into the soil. So plants can absorb right until they reach what's known as their critical load, at which point it becomes poisonous. It can lead to species destruction. Too many nutrients are a bad thing. Too many nitrates, for instance, lead to algal blooms. And we talked a lot about algal blooms this semester. Algal blooms are going to lead to phytoplankton growing. They will take they'll take oxygen out of the water at night, leading to anoxic or lack of oxygen areas that fish can't survive in. kills off ponds, kills off rivers, and it just really leads to a stinking mess. The only organisms that tend to grow there are anaerobic. So with anaerobic organisms growing, honestly, all you have is a bacterial soup. You don't have fish living there. You don't have those organisms that we need to survive. These are dead zones. Like at the mouth of the Mississippi River, you don't see many living organisms. We release a bunch of toxins into the environment. From industrial processes and just from our own biological waste. You can see here, basically, this whole process of wastewater reclamation is happening right next to the ocean. You can imagine that there's several spills there. As we release toxins into the environment, say lead, the James River, used a lot from industrial manufacturing. There's a lot of heavy metals that are in that water. Those toxins are going to be taken in by organisms that are at the lowest trophic levels. Think single-celled organisms. Those single-celled organisms aren't dying from it. They're surviving, they're metabolizing it, they're incorporating it into themselves. Those organisms that have incorporated some heavy metals are being eaten by larger organisms. Those large, and they eat in large numbers. Those larger organisms then have higher concentrations of heavy metals. In the James River, we used to have a mussel, the James River mussel, that basically got wiped out because of heavy metals. They're filter feeders. They'd build up these the heavy metals, they became toxic in their bodies. Well, what ate the mussels? Various vertebrates, people. So those toxins got stored in the fats of other organisms. It's one reason, I don't think any of you guys, I'm not going to make any assumptions, they tell pregnant women don't eat fish more than once a week. Why? Because of these heavy metals that build up in the fats. They don't want them to influence the development of the offspring. This process is known as biomagnification. As the organisms at the lower trophic levels take in heavy metals, they're eaten by organisms higher up, which then concentrate those heavy metals in their tissues, which are eaten by organisms higher up, which concentrate the heavy metals even more. And guess what? Where do humans lie on this chain? The very top. So those organisms we eat are going to be the ones that are most highly exposed to the heavy metals. The ones that have them most in their fats. And then you eat them, and then you get cancer, and then you die. Cool. We know we've talked about greenhouse gases before. Climate change is caused by an increase in greenhouse gases. Greenhouse gases are those that are going to trap solar energy in the atmosphere. The way it works is basically carbon dioxide and methane even more so than carbon dioxide, are going to absorb the infrared radiation that's reflected from the Earth. So you have solar light coming in, you got kinetic energy from the sun coming in and striking the Earth. The Earth then will emit infrared radiation. So you have all of this sunlight coming in, being absorbed, and then reflected. Infrared radiation is going to be absorbed by carbon dioxide and methane, trapping it in the atmosphere. The more carbon dioxide and methane you have, the more more infrared radiation is recaptured, the hotter the planet is. This is, of course, causing a steady increase in temperatures. What was it? In your lifetime, in the past few years, I don't know if you remember, they were talking about we've got to stop the Earth from getting 2 degrees Celsius warmer. Do you guys remember that? Yeah, and that was like critical. We have to stop that. We've gone beyond that threshold now. The Earth will increase more than 2 degrees Celsius. Now we just got to deal with it. Trying to slow it down, we don't want it to increase even faster, but it is. So you have all the nations talking, let's slow this down. They're talking. Not much is happening. What are the effects of this climate change? What are the effects of having more heat? Basically, organisms that can't disperse quickly over a long distance won't survive. Trees don't move much. So as temperatures change, you're going to see a lot of certain trees are going to die. You're going to see hardwood trees expanding more northward. You're going to see softwood trees like pines also expanding northward. And you're going to see more die off along the equator where the temperatures are too hot. That's called a polar migration. You're going to move toward the north or to the south, moving toward where areas are cooler. What happens to the organisms that live at the North and the South Pole currently? They get displaced or they die. As I mentioned earlier, crabs are disappearing from the Arctic Ocean. Why are they disappearing? It's thought to be too warm for them now. They can't go anywhere else. It doesn't get colder than the Arctic Ocean. So we're losing the crabs. Something will replace them. Something from the Californian waters will end up moving northward to replace them, but it's just not there yet. And we don't know what it's going to be. Might not even be something edible. What? Otters, right? Might not even be something edible for us. We're going to see changing weather patterns. Particularly, we're going to see heat waves, coastal flooding, extreme precipitation, and severe droughts. These are going to be happening over the next several years, several decades. They're going to get worse and worse and worse. There's limited evidence that hurricanes and tornadoes are increasing due to changing weather patterns. There's some, but not much evidence on it. Basically, you guys have, again, your lifetime, you've seen hurricanes get more and more and more powerful over the past 20 years. We don't know, though, right now if that's just a localized to this time frame or if it's caused by global warming. We don't know. We do know heat waves, coastal flooding. If you go out to Norfolk, when it floods, literally water comes out of the sewers because the streets can't handle it. The ocean level has gone higher than the city, so the whole area floods. I know you've seen extreme precipitation. What was it, last year? The whole area around here flooded. Roads are closing. Roads are getting washed out. Trees getting uprooted. And as much as you have extreme precipitation, you also have severe droughts at different times of the year. Yay. Not only, though, are there changing weather patterns, they're changing water patterns. Guys, we talked a lot about the way the ocean currents work, and the reason the ocean currents work the way they do is because of the way the sun is striking the planet. The way the temperatures of the water level, the temperature of water at any given point is. So we're going to see a lot of what's called ocean acidification. Ocean acidification is a decrease in pH of the oceans because it's absorbing as much carbon dioxide as it can. That will kill off lots of different organisms that rely on steady chemical levels in the oceans. As the polar ice caps melt, the sea levels will rise. It's not going to like wash it. We're not going to be beachfront property for a while, so don't worry about that. You're going to have changes in ocean currents. That's going to be the biggest issue. Right now, what manages why we have a temperate environment where we live. We are at about the same latitude as England. It doesn't feel like it. They're cold and rainy year round, right? Basically what happens is we have that Gulf Stream that circulates in the Atlantic. The reason it circulates is because you have temperature differences, but you also have salinity differences. As fresh water pools into the Atlantic, you're going to see that slow down. That will change our climate here. And of course, severe weather events. So yeah, super fun. Basically, the world is changing. You guys are going to feel its effects more acutely than any other generation ever. Sorry. It's not going to be fun. You're going to have a lot of damage. Crops are going to get destroyed. We have a carrying capacity for humans. And we're getting to the point where we're almost to the point we're going to exceed that, especially as more and more crops get damaged because you have less resources, which means the carrying capacity drops. The bottom represents, yeah, so here we got a chart. The bottom represents years. The side represents the world population in billions. Check it out. 10,000 years ago, not so many humans. Less than 1 billion, a lot less, so much less it doesn't register. Yep. Yeah, because people reproduce. What kind of scale is this that we're looking at, where it starts off slow and goes really fast? Exponential growth. Over the last 500 years, we're looking at exponential growth of the human population. Resources were there. Resources have always been there. Part of it is technology and surviving childbirth. You survive childbirth, you have more kids, you protect those kids, they have more kids. For several hundred years, the norm was to have 5 to 10 children. Right. But now you got fewer dying, which means population's going up. Good news-ish. What you're not seeing on this is, at this point, the population, for the past 40 years the population growth is slowing down dramatically. It's no longer exponential. In several industrialized nations, in fact, the population is decreasing. Since the 1960s, not all over the world, in mainly the industrialized countries, the population rate has begun to decline, the population's numbers. And that's likely due to voluntary birth control. Voluntary birth control was a game changer. By having birth control, people are having children now not whenever, but only when they want to, in certain countries. You'll notice in other areas, you're going to start seeing, you see a lot of increases. What this map is showing you is how many children are in each household on average. You'll notice that in a lot of the industrialized countries, Europe, America, South America, Australia, you're at 1 to 2 children per family. That's sustainable. Basically, you got 2 parents, each have 1 to 2 children. Both of them produce 1 to 2 children. That's population replacement. That creates a stable population. If you look in other areas that are just now becoming industrialized, the numbers between 2 and 3, that's okay. We can survive that. In other areas that are more still agriculturally based, you have 5, 6, 7 children per family. That's not sustainable. It's the industrialized nations that you're at equilibrium. Here, this bottom part of the graph shows population growth in industrialized nations, and it's less than 1, which means you're not getting any growth. But in less developed countries, you have a lot more growth. And that's going to be primarily attributed to advances in medical technology. So some countries, Canada, Germany, England, Japan, they're decreasing in population. The only way they maintain their population is through immigration. The United States is getting there. Other countries have continued growth, and that continued growth is attributed to you have culture interacting with modern technology. The culture was have lots of children. Modern technology, though, is allowing most of those children to live. We expect that it is likely for these countries becoming industrialized, the numbers will drop over the next 4 or 5 decades until we reach equilibrium. So we expect about 8.1 to 10.6 billion people to live on Earth in 2050. So what we're seeing is, billions of people. 2050, we're hoping it starts to even out. And that's projected based on the speed at which industrialized nations are reducing their birth rate. So 8.1 to 10.6 billion is what we expect on Earth. The global carrying capacity, it's estimated from between 1 billion to 1,000 billion. Okay, that's a lot. 1,000 billion is just completely wrong. But that's what some experts have put forward. Most estimates for the global carrying capacity right now are between 10 and 15 billion people. So what that tells us is right now we're living on an edge. In we said 2050, we're going to be at about anywhere from 8.1 to 12 billion people. We may be at carrying capacity then, if everything stays the same way it is now. Maybe we'll be sustainable, but we're only going to be sustainable if we have the resources that we have available now, which, due to changes in the climate, we may not have. The estimates do not include crop loss due to climate change. So if we want to maintain our civilization, because without having stable carrying capacity, you're going to see wars for resources. 100%, because everyone wants to live. We need to figure out ways to increase crop yield, or at least maintain crop yield, regardless of climate change. And guys, this is where you'll see my views. The way I think we do this is through genetic engineering. We increase the amount of yield that we're able to get per crop. Other people might say, go straight up organic. You can't. The reason organic foods cost so much and they're hard to produce is because they produce a smaller yield. We need food that we can eat. And that's my take. So there we go. We are super close to our carrying capacity. Reproduction right now outpaces food acquisition. We need food. If we don't have food, we die. Or at least we have to fight for those resources. We talked about competition. So I hate to end the course that way, but basically, we're on a real downward trend. It's possible that we can make it through it with technology. Maybe you guys will come up with the technology to get us through it. I'm hoping you do. Maybe I would have served some useful purpose in life by teaching the next person who's able to figure this thing out. But otherwise, just be ready for the next 50 years.